Hey guys, what's going on? It's Danny, and today we're going to be talking about LeetCode number 2, add two numbers. This problem gives us two numbers stored as linked lists in reverse order. They are non-negative, and each node contains a single digit, and you are tasked with adding these two numbers and finding the result. The result is then returned as another reversed linked list. So before we even talk about what this is even asking, it's just asking to add two numbers, right? Let's just look at the test cases. So we have 2, 4, 3, 5, 6, and 4, and that equals 7, 0, and 8. So they're shown in reverse order, and we have to add them to get the answer. So we can just add up numbers that are in the same place value, because that's how addition works, right? You can't add 10 and 1 and get 20, just like you can't do that. So let's find numbers that are in the same places. So if it's stored in reverse order, we have a number like 100, right? That'll be stored as 0, 0, 1. And the first node in that linked list is 0, which is the ones place. So it looks like each of these numbers starts with the one place. So let's start with that addition, right? Let's add the ones place first. So 2 and 5 adds to 7. That makes sense. Then 4 and 6, that's 0. But wait, it's 10. But it's 10, but the construction is that single digits only in each linked list. This means that this carryover of 1 gets put up here. Let's draw that a bit clearer. It gets put up here. And then we add these up, and we get 8. And so now we can kind of visually see how we're adding. We're just basically doing the addition we learned in elementary school, just kind of backwards, right? Now, how can we turn this into an implementation? Well, I'm not really sure yet, but let's start looking at the other problems. Other test cases. So if we have 0 and 0, we get 0. I think that makes sense. 0 plus 0 is 0. Then the last test case, we have 7 nines and 4 nines. So this is our equation for this, right? So let's think about what do we do again? We first add the ones place, because those are the same value. So 99 gives us 8. Not 8, it gives us 18. But we can't store anything greater, so single digit. So we carry over the 1, and we work for the rest. We get 19, carry 1, 19, carry 1, 19, carry 1, 10, carry 1, 10, carry 1, 10, carry 1, finally to here. And that's how we got that answer. Awesome. Cool, but when I'm thinking about that in code, I mean, if I'm adding both of these pairs, in this scenario, it actually ends earlier. So if I was to add these two, these two, these two, these two, once I go to add these two, because this node is missing, we're actually going to get an error because it's a null node. So that's just a property of linked lists. So if you're unfamiliar with linked lists, I'm going to send you over to my other video. You should check that out and come back when you're done. So because we know that we can't access nodes that are out of bounds, we need a way to handle that, right? So if the node doesn't exist, that means there's nothing in that place to add, which means we shouldn't add anything and we should just have the other number, plus the carryover, of course. So as we're going through both of these, we need to make sure to terminate before this one's ready. Now, I'm not exactly sure how this would work, but I think I have a solution I could start working towards. So I think I'm going to try doing that. So let's check it out.
All right, well, I guess let's just start working on the code right away, right? So the first thing it asks for is a return type. It's a list node. So let's create our answer. We have a list node. Let's create a new list node and store it into our answer variable. Then we also need a list node that can go through our answer, right? We can have one that sits at the front and then one that passes through it, which is going to be how we generate our solution or our sum over the course of the problem. Now, we need to have a loop, right? We established that. We need to make sure we're going as long as we still have more of these L1 and L2 nodes to access. Well, that just sounds like as long as list 1 is not equal to null, or if list 2 is not equal to null. So if either of the list nodes exist, we need to continue through it. Or what else? I mean, if they're both null, how could we still keep going? Well, if they're both null, we could still keep going if there's a carryover, right? If they added and there's another thing that we need to carry over, we need to account for that. So if the carry does not equal 0, because those are the times when our loop would end, okay? Well, we need to have a global carry variable, that way their solution compiles. But now, what we want to do inside of this, right? Well, first thing we want to do is we want to create a sum, right? And the sum is equal to, well, the first digit and plus the second digit plus whatever the carry is. So we can have list1.value plus list2.value plus carry, but sometimes when we're going through this, I feel like these nodes might be null, right? Because these are all OR conditions, which means list 2 could be null. So, and if they're null, we're going to get an error when we try to access the value field. So instead, let's just store it into a digit and check if they're null. So we can use a switch case for this. So if list 2 is not equal to null, then if it's true, let's set it equal to list1.value. So let's set the digit equal to list1.value if list1 is not null. Otherwise, if it is null, if there is no number there, let's just set it equal to 0 because there's no digit to add. And then let's mark this as digit A, and then we can have another digit B for our other linked list. Cool. And then let's add these instead. So we have our sum, right? That's exactly what the total is, but what are we storing? Well, I mean, the first thing we're storing, I guess, is the carryover. The carryover is just the sum divided by 10, right? We just care whatever the carryover is. But the digit that we're going to be storing into it is just the ones digit. So if we do modular 10, we'll get the remainder. Now, with the sum, what if we store it into a new node and then append that node to the next node of our where we're looking at in our answer? So visually what this looks like is we have our answer node here on the left, and then we have another node that goes through it, right? And below we have our current node. So if we set the current.next equal to whatever new node we just created, it puts it here, right? It attaches this node into it, and then let's move there. Let's do current equals current.next. What this will allow us to do is go to our next place because that's the current one that we're looking at, right? If we were to return, that's all we'll go to, but if we need to add a new one, we will, which is what this is saying. We'll set the next one, if we need a new one, to whatever this new node is, to whatever new value we need to append to the end. We can just add. Now, finally, what we need to do is we need to iterate through our other linked lists. So let's do the same check again. If list 1 is not equal to null, let's set it equal to list1.next. Otherwise, just set it equal to null. Same thing for number 2. And then, okay, so we go through, we find the digits we need to add, we add them, calculate the carryover, store it in a new linked list, go to the next spot in that linked list, go to the next digits to add, and then start back at the top. I mean, that works. All right, well, what do we return at the end? At the end, we need to return our answer node, right? But wait, this is a new node stored in it. And when we create current, we never actually change this value. Instead, we just immediately access current.next. I think we need to return the next value instead because that's what we've been changing, right? The answer was just sitting at the front. We need to return what it was looking at. Let's see if our solution submits now. Cool.